I'm really pleased to be among you here in the Future Build conference among you. I'm a Greek architect. My name is Antoniki Giannatou. And I would be really pleased to share with you some results of my recent research on clay-based renders, entitled Clay-based Renders with Waterproofing and Vapor Permeability Properties. I completed this study, this research, during my master's degree in the Center for Alternative Technology, and since results were promising, University of Bath awarded me with a PhD studentship in order to further optimize the material. So, due to the need for energy savings in UK, there is a huge investment in energy retrofittings, since 25 million houses need refurbishment by 2050. However, research completed by the British Research Establishment and the Northern Ireland Housing Executive estimated that energy savings were reduced by up to 50% than expected due to water ingress within the building fabric, causing insulation fail and mold. This implied that current lime and semi renders could not combine high waterproofing against rain with high breathability against mold, while maintaining a low carbon profile at the same time in order to comply with the new energy standards for energy efficiency. So there are multiple papers in academic literature that display lime and semi renders water absorption, vapor permeability, and high carbon profile. However, this research combines the two aforementioned properties, and it's quite indicative. We see that the paper examines the absorptivity of mortars obtained from UK houses treated for rising damp. It examines 33 lime and semi renders aging 5 to 150 years, applied on brick and stone walls all over UK and treated for rising damp. So we see here in this diagram displaying water absorption per time, we see that the higher water absorption is displayed by lime renders aging 160 years to 5 years old, the more recent ones. However, according to the research, these lime renders displayed high vapor permeability. At the same time, on the other hand, we see that semi renders display lower water absorption, especially those enhanced with synthetic polymers, but according to the research, these semi renders display low vapor permeability. In fact, they display mold in the inside of the wall and cracking on the outside of the wall, which enhances water ingress, and then this is the reason why they require treatment for rising damp. At the same time, another interesting property is sulfate salts. Sulfate salts is the white stain, the white discoloration we see on the surface of a render. So we see here that almost all renders, especially those with high absorptivity, displayed high levels of sulfate salts. So this is important. We have to keep in mind that lime render shows high vapor permeability but low water, but high water absorption. Semi-render shows low vapor permeability but high water absorption, and both of the materials show high levels of sulfate salts. Regarding the carbon emissions of lime and semi renders, this is very indicative, a very important paper, indicative paper, because it displays and compares cement, lime, and clay plasters environmental footprint. Specifically, it compares their embodied energy in megajoule, their carbon emissions in kilograms carbon dioxide equivalent, and their environmental footprint in millipoints. The embodied emissions, the embodied energy in megajoule is the energy from cradle to gate, as this research calculates. This means from extraction to site. Both the carbon emissions are calculated in the same way, And the environmental footprint is the environmental impact on 19 indicators on air, water, and soil. So here we see that clay plasters display half the embodied energy, 1/7 of carbon emissions, and almost 1/3 of the environmental footprint compared to lime and semi-renders. So, acknowledging all above, we could say that, according to academic literature, lime and semi-renders display medium performance in all these aforementioned properties. On the other hand, clay is a material that has, according to history, shows indications that may have potential to outperform in some of these properties, but there are no sufficient academic literature to support it. So, during my master's degree, I tried to work towards this direction, to try to cover the gap if I could. So I tried to produce and test an alternative to lime and semi-renders based on clay, trying to combine these three properties: low water absorption, high vapor permeability, and low carbon profile at the same time. So 15 different specimens of one clay synthesis were combined with 4 waterproofing agents, which were one synthetic agent, synthetic polymer, siloxane, and 3 organic natural agents, casein, and 2 types of cornstarch. In addition, they were combined with 2 breathable agents, perlite and straw. Casein is a constituent of milk, and as we know, cornstarch is a plant-derived, plant-based derivative in powder form, and siloxane is a synthetic polymer. So these renders were tested for many properties in laboratory conditions following strict British guidelines. So for this presentation only, some of these properties will be presented, which are their physical properties of density and porosity, and their Higg-grade properties of water absorption and vapor permeability. So, regarding results, here we see the results for density and porosity. The lime render control is the control render, as we say, that all specimens will be compared to this one at the end. The basic is the first specimen having no additives at all. These four are the waterproofing agents we add in order to the basic in order to enhance the waterproofing performance of the material. These two categories are the same with the first one, but here perlite is added and here straw is added. So, according to the result for density and porosity, polymers not only significantly reduce the specimen's density, but at the same time, they beneficially and substantially reduce the specimen porosity, but not lower than 6%, as we see here. This implied that the polymer nanostructure reduced pore sizes, but did not block them. Specifically, we see here the density after the waterproofing agents. We see that the density is decreased, and also the upper porosity is substantially decreased to 60%, from 33% to 60%, compared to air lime render, which porosity is 40%. Regarding water absorption and vapor permeability results, we see that polymers not only substantially reduce the specimen water absorption, performing as exquisite sealers, but at the same time, they maintain the vapor permeability balanced. This implied that the polymer's nanostructure reduced pore sizes so as to block large water molecules to enter, but allow small vapor molecules to pass. As for aggregates, they display, let's say, a neutral or detrimental performance at the end. So finally, we could say that at the end, 3 of the specimens casein-based siloxane and cornstarch displayed substantially lower water absorption compared to lime render, and also almost all specimens displayed 2 times higher vapor permeability compared to lime render. This is the vapor permeability resistance. It is the opposite of vapor permeability. That's why you see that the values of the specimens are half. In fact, they are 2 times higher regarding vapor permeability compared to air-lime render. Here we see the same, that the lowest water absorption is displayed by siloxane-based specimen, casein-based specimens, and at the end, these two are an air-lime render water absorption is almost 8 times higher than siloxane-based or casein-based. So, summarizing, we could say that with a substantial contribution of polymers, and especially of siloxane and casein, 3 out of 15 specimens of the research outperform in both water absorption and vapor permeability. First, outperform the air-lime control of this research, which this one. Secondly, outperform 6 of the most well-known and widely used market lime renders in UK. These are Mapei, Unilid, Kame, Bomet, Limetech, and Remus. And also outperform clay-based renders of academic literature tested by significant researchers that they were enhanced with similar or the same additives. So further research is needed in wide-scale application or in external weather conditions in order to further verify the results. Also, all the properties should be tested, like compressive and adhesive strength, durability, freeze-thaw cycles, fire resistance, thermal conductivity. However, if results are promising, then application could be various, not only in existing porous structure, but also in new ones. For example, in existing porous structure, it could be historic stone buildings, or brick porous structure, or it could be high levels of areas of high humidity levels, like kitchen or bathrooms, or even underground spaces, basements that require low water absorption and high vapor permeability. In addition, there is a world cultural heritage, a huge world cultural heritage that all over the world, in Africa, Middle East, Latin America, that it is consisted of earthen villages, earthen structures, or even significant mosques that require reapplication of their clay renders every 5 years. So there may be a potential that these materials, clay renders, enhanced with waterproofing and vapor permeability agents, could comply with these structures. So also, other benefits of the material are, besides their water absorption and vapor permeability performance, it's their low cost, their handmade profile, their biodegradable properties, but far more importantly, their low embodied energy and their low carbon emissions, since the first is half and the second is 1/7 compared to lime and cement renders as we referenced. Thank you very much for your attention.